right, so we've got this quadratic equation and we've already been given that the discriminant is less than 0, so it's clear that it's going to be, first of all, it's quadratic, it's got 2 roots, the discriminant is less than 0, so these are going to have to be a complex conjugate pair of roots, and we are given them alpha equals x plus iy and beta equals u plus iv. So we already know they're going to be a complex conjugate pair, but in part B here we've got to prove it, so we won't assume anything. It does say by considering the sum product of roots, so let's do that. So we know that the sum of roots, so in this case alpha plus beta, is going to equal to negative b on a, and we know that a, b, and c are all real. So this is going to be real. All right, so this is real, which means that the imaginary part of alpha plus beta has to equal 0. Same thing with alpha beta, we know that's C on A, therefore it's real. So that gives us that the imaginary part of alpha beta is also equal to 0. So let's have a look at those two things. So we know if we add alpha to beta, the imaginary part would be y plus v. So if y plus v equals 0, we know y equals minus v. And let's use that in the imaginary part of alpha beta. So the imaginary part of alpha beta is uy plus vx. So that also has to equal 0. If we use that, y equals minus v here, actually we'll just change v out. So we'll still keep y there, but this will be minus yx or xy. So we can factorize that. All right. Now, if we're saying that equals 0, then either y equals 0 or u equals x. Now, y can't, I'll just put here, but y can't equal 0. If y was equal to 0, let's go back to up here. If y was equal to 0, then the root alpha would be purely real, which we know it's not. So we could say since the discriminant's less than 0, so we've got complex roots. So it can't be purely real, that root, so y cannot be equal to 0. So therefore we've got y equal x. Now if we use that, or y minus x equals 0, so sorry, u minus x equals 0, so u equals x. If we use that back into alpha and beta, so we know, let's keep alpha as x plus iy, and let's make beta equal to, all right, so it is u plus iv, but we know that u is equal to x, so we'll put x, and we know that v is equal to negative y, so negative iy. So you can see that b is the conjugate of alpha, or alpha equals the conjugate b, same thing. So either b equals conjugate alpha or alpha equals conjugate b, but that's how we're asked to state it. So we already know that from the question, really. So we know that it's a quadratic, it's got 2 roots, all the coefficients of this quadratic are real. So if the discriminant's less than 0, so basically if the roots are not real, then they have to be a conjugate pair of complex roots.